Working with electricity is common in most business units in ABB, and no one understands better than you the extent of the risks you face on a daily basis. You have received training on electrical safe working practices, the processes for risk assessment, and the application of the hierarchy of controls to either eliminate or mitigate electrical risk to an acceptable level. You have a full understanding of what you have to do to keep yourself and others safe, and all of the necessary elements to create a safe working environment. At times, you may, due to time pressure or customer pressure, consider not following these practices. Don't do it. In this scenario, the ABB engineer arrives at a client site to perform some switching and maintenance work. The customer requests that the work is carried out without full isolation to reduce disruption. Remember, you are expected to be the expert, and customers often underestimate the risks of working on or near electrical lines, equipment and systems. As a result, you may be asked not to place the equipment in a safe working condition because they're concerned about lost productivity. You must politely and respectfully refuse. You need to respectfully help the customer understand why it's in their best interest to follow good safety practices. Explain that based on your experience, you believe the best thing to do is de-energize, verify, secure, and in most cases, earth or ground the equipment before proceeding with the work. Your main goal at this time is to help the customer understand that following your advice is in their best interest, but there will be times that you will not be able to convince them. When this happens, apologize to the customer and explain that you do not feel safe or comfortable doing the job. This is a good time for involving your manager in the decision not to proceed with the work. The bottom line is, you should never do work that you feel is dangerous to you and others in the area. When you are comfortable that you can safely perform the work, there are things you must do to ensure the highest possible level of safety. These are the 7 steps that save lives. Step 1. Prepare for the work. Do an on-site risk assessment or a job hazard analysis and be in possession of a clear work order to execute the work. Where required, the access or work permit is to be obtained by a person who is authorized for the specific electrical system. Engage the person responsible for electrical equipment or system to review single-line diagrams, schematics and switching plans. Ensure the competence of workers. Check for proper tools for the job. Determine and select the proper ARC-rated personal protective equipment, PPE, and associated PPE as defined in the ARC Flash risk assessment. If an ARC Flash risk assessment has not been conducted, then the ABB matrix shall be consulted to determine the appropriate ARC-rated and electrical PPE. Finally, decide on the appropriate work methods and initiate the permit to work process. Step 2. Clearly identify the work location and equipment. Use your senses to identify problem areas. Define the work area via barriers and barricading, and label the equipment by placing warning notices on any adjacent panels you're not working on. Also, avoid distractions such as talking or texting on the phone. Step 3A. Disconnect all sources of supply. Where possible, ABB recommend that switching should be conducted remotely. If not, observe switching from a safe distance well beyond the ARC Flash boundary. If switching is performed prior to arrival, walk down the equipment to check the isolation points upon arrival. When required, perform switching only if properly trained and while wearing the proper PPE identified in Step 1. Step 3B. Secure against reconnection. Secure against reconnection by applying lockout-tagout and, if possible, avoid allowing other work to take place at the points of isolation. If there are multiple points of isolation, group lockout-tagout shall be implemented with the person in charge of work, or PICW, acting as the group lockout-tagout leader. Step 4. Verify the absence of operating voltage. Utilize only properly rated and calibrated voltage detection devices and wear the proper PPE identified in Step 1. It is extremely important that you test the voltage detection device on a known live source or by using the detector's test button if designed into the device. Then test for the absence of voltage. Ensure to test for loss of voltage on all 3 phases where 3-phase applies. Finally, test the voltage detection device once again to ensure it is still working properly. This 3-step method is required without exception. Step 5. Carry out earthing and short-circuiting. Close and lock earthing switch if applicable, or apply portable equipment for earthing and short-circuiting while wearing the proper PPE identified in Step 1. Also, use insulated tools when required. Be sure the equipment is free of any residual charge or induced voltages and short-circuit any fault current. You may need multiple earths between supply sources and the point of work, commonly referred to as local earths. Ensure that you earth both sides of the apparatus being worked on. Step 6. Protect against adjacent live parts and take special precautions when close to bare conductors. Determine minimum approach distances and apply screening. Take special precautions such as wearing the properly rated insulated gloves and leather overs and using insulated tools for inadvertent contact potential. This is especially important when marking live components or cables or while placing protective barriers or screens around the area as you prepare to do the job. In especially dangerous situations, like working closer than 1 meter to the live connections, or where there's low lighting, difficult access or higher voltages, take extra precautions. Now that you've created a safe work area, you need to take the final step before beginning work, which is Step 7. Complete the permit to work and walk the permit. The PICW now gathers the working group and together they walk down the permit to work to check isolation points, verify all circuits are isolated and secured, ensure all parties are integrated with the lockout-tagout and check that the earths are properly applied. The PICW then answers any questions from the working group, ensures the work can proceed without danger and validates the permit to work. The person responsible for the electrical equipment or system at the job site or permit issuer then signs the permit to confirm that the facts have been communicated. You will also sign on to the permit confirming that you understand the safety aspects of the job and agree that it is safe to begin work. The permit to work formally documents many critical facts about the job, including the scope of the work, where it will be done, the safety precautions taken, and individual responsibilities. Understanding and agreeing to these facts is essential to the safe completion of the work. Once you sign, you are responsible for ensuring the safety of yourself and anyone else in the area while doing the job. You can't change what's been described in the permit without the agreement and signature of the permit issuer. Remember to be aware of induced voltages from nearby equipment. And of course, you should wear all of the appropriate PPE for the job. Make sure anyone working in the area, especially people who don't understand the dangers of electricity like crane drivers and civil contractors, know where the live parts are located. Continue to reassess the risks, asking yourself these questions. Are there any issues with the live equipment? If this equipment fails, could it affect your safety or the safety of others? Could you directly affect live parts, particularly when handling cables or conductors or using large plant equipment? Could you indirectly affect live parts, for example, interfere with earth conductors, protection and control supplies, or heating and cooling? The PICW must conduct the pre-job briefing for the work team to be sure everyone understands how the job will be done and what safety processes are in place. If you leave the work area for a break or any other reason, you must sign off the permit. When you come back, You must engage the PICW to be briefed on any changes that may have occurred during your absence and sign back onto the PTW. As an experienced engineer, you are responsible for assessing each job and confirming that it can be done safely. If you aren't comfortable with doing the job, you should discuss this with the customer's responsible person and your manager. If you aren't able to resolve your safety concerns, respectfully decline to do the job and ensure the customer understands why. When you are confident that you can safely do the job, follow the 7 steps that can indeed save lives to ensure that the job will be completed in a safe manner and that you will go home healthy and injury-free at the end of each workday. Here are the 7 steps once again. Step 1. Prepare for the work. Do an on-site risk assessment of job hazard analysis. Step 2. Clearly identify the work location and equipment. Step 3A. Disconnect all sources of supply. Step 3B. Secure against reconnection by applying lockout/tagout. Step 4. Verify the absence of operating voltage. Step 5. Carry out earthing and short-circuiting. Step 6. Protect against adjacent live parts and take special precautions when close to bare conductors. Step 7. Complete the permit to work and walk the permit.